In this video, we'll take a quick look at how to deal with geometry as a whole inside of Python SOPs. Alright, the first thing that we want to do is take a look at how to activate this group parameter so that our Python SOP will only color whatever is specified here. So if we put something like 0 to 9 here, our Python SOP will only color points 0 to 9, or even if we put something like 0 to 100. So let's take a look at this first. So the first thing that we'll need to do in order to make this work is get this value. So let's just create a group variable and say node.evalParm group. So this group variable will contain this value. Alright, so how do we make this work? Well, the geometry object in Houdini actually contains another way to get at the points or the primitives. And this is called glob. So basically you want to use the glob points function. And what you can do with that is give it a pattern, say group, and it'll only return the points that fit this pattern. So now if we hit apply, we minimize, come around here to the back, you can see that it's only coloring those points. So if I said 0 to 200, it colors those points too. Now the cool thing about this function is that if we were to create a group node and make it points, call the group blorg, and maybe this pattern is 100 to 500. So it's only those points in there, 400 points in blorg. So now if we were to go to experiment, we can make group blorg, and that actually works. So glob points will actually accept group names as a pattern. Now there is one annoying thing about this, and that is that you'll notice if we clear this group parameter, our node errors, and it tells us that we have an invalid pattern. And that's because glob points doesn't know what to do if you just give it an empty string. Moreover, if we give it a star here, you'll notice that it's not coloring all the points, it's only coloring blorg still. This is because when glob points gets a star, it's expecting you to be saying, I want all of the groups, rather than just all the geometry. So what we can do is just account for that. So if we bring it back our code here, and instead of just calling this glob points function directly, we can control X and store it in a variable. So point list equals control V. So point list will contain whatever our group is. And then we'll just loop over point list instead. And this is an advantage because then we can just check if group, do that, else point list can just equal geo.points. So now if we hit apply and we clear this field, it'll just color all the points on the sphere. Okay, so let's take a look at some other things that we can do to operate on geometry as a whole in Houdini. So the first thing I'd like to do is if we come back to our type properties dialog, what happens if we go to parameters and we want to add, say, a rotate parameter. So float vector 3 and just call it rotate. Hit accept. Now we could do a very expensive rotation operation on the points themselves, moving the point positions, do all of the transforms on normals ourselves, and try to handle it all by hand. But that would be very expensive, especially in Python, and it would also be a bit of a headache to implement. Luckily, if we go back to our code section, there is a way that Houdini handles this. So we'll just come down here. I'll just add a comment that says for rotations. Okay, so the first thing we'll need to do is we'll need to get the values of these parameters from our parm tuple. So we can say rotates equals node.parm tuple rotate.eval. That gives us all three rotation values. Now the function that we're going to be using to make this work is on the geo. So if we say geo dot, so what we'll want is the transform function. And what this wants is a matrix. So you give it a transformation matrix and it applies it to the geometry. Alright, so how do we get our transformation matrix? Well, there are a couple of different ways that we can construct a transformation matrix, but luckily in Houdini there is a function for that. So we can say xform matrix equals who.hmath.build rotate. And all this function wants is your rotation values, so we can just say rotates directly. Now notice that it has an optional argument for the order, but we're just going to leave it as xyz. Close parenthesis, and now we can just say geo.transform xform matrix. So now if we hit apply, you'll notice that I can rotate it. Now this is really hard to see because it's just a sphere, so let's just go ahead and add a mountain SOP, just so that we have some different things in there. So now if I rotate, you can see that it actually does rotate. Alright, very cool. Now the interesting thing about this is if we turn on normal display, you'll notice that there are no normals, but if we did add some normals, say with a facet SOP that post-computes normals, now we have normals on here. If we run our rotation, notice that my normals actually transform with the geometry. This is one of the advantages of doing this rotation this way instead of by hand, because Houdini will actually handle these attributes for you. There's also another interesting result of this, and that is if we go back to our edit type properties, when we're creating attributes, let's say we want to add an attribute called blorg, and maybe just make it point along the x-axis, or the z-axis rather. If you notice in the add_attrib function, if we get it to bring up the tooltip, there's this transform as normal argument. So if we set that transform as normal equals true and hit apply, you can see there's our blorg attribute. We'll need to turn off normal display and then hit D to go to display options, go to markers, and then create a custom attribute visualization for blorg. Then hit apply, and let's turn that on. So you can see that since we set that flag that says transform as normal, now when we call this transform attribute, it'll actually check all the attributes that have that flag set, and it'll transform those for us. So that's pretty cool. Alright, so now we know how to transform geometry as a whole. Just close the display options here and bring up the type properties dialog. Let's take a look at how to actually create new geometry and delete geometry using our Python SOPs. Alright, so the way that we do this is we can use more functions on the geometry object. Say for geometry creation. Alright, so the first thing we want to do is actually create some new points that we can add to our geometry. For the purposes of this demonstration, I'm just going to create a list of points that I want to add. But probably for a real project, you'd want to generate this list using an algorithm. So what I'm going to do is say create point list equals, and then what I'll do is I'll just make a list of point positions. So we can say 0, 0, 0, maybe 0, 0, 2, and 2, 0, 2. So now what we can do is loop over that. So we can say for cur point in create point list. And then, actually let's just say for position and that. And then we can say cur point equals geo dot create point. And this will just add a point to the geometry. It won't actually put it anywhere. So the next thing we need to do is say cur point dot set position. And this will just put the point at these coordinates. So now if we hit apply, one thing I'd like you guys to notice is that the geometry here, this old sphere, is still there. And that's because we're simply adding points to the geometry, we're not removing anything. And we'll look at how to deal with that in a moment. But first let's just see if our new points were added. So I'm going to turn on point numbers, and you can see that there is a point here, point here. It's hard to see, but there is one at origin as well. So what if we want to create a polygon out of these points to form a triangle? All we have to do is say cur poly equals geo dot create polygon. And then we can just say cur poly dot add point cur point. Now this is actually wrong. What we need to do is create this polygon outside of the loop, because otherwise it's going to be creating a polygon for every point that we want to add. So let's just go ahead and Control X that and create it here and hit apply. Oh, sorry. So it's not add point, it's actually add vertex is the function that we want. Hit apply, the error goes away, and there's our very lovely triangle. Now, it's black because the color attribute is 0 by default on there. But we'll not worry about that right now. For now, what we'd like to do is just get rid of this old geometry. So the easiest way to do that is before we do any of this nonsense, of the creation nonsense, we just want to say geo.clear, and that'll delete all the geometry that came in beforehand. And now you notice that there's no color attribute either, so it's not black anymore. Okay, so what if we wanted to have it, instead of just deleting all of the geometry, what if we wanted to have it only clear those points that are referenced by this group field? Well, we already have those points that we got up here, so that's stored in the point list. So all we need to do is, instead of calling the clear function, we can call geo.delete points. And this wants a list of point objects, which is exactly what we have here. So we can just say point list, and we're done. If we hit apply, since this is empty, it actually deletes all of them. If we said something like blorg, it only deletes those points that are part of the blorg group. If we said 0 to 200, it still works, just deletes those points. Alright, so we've got our cool little monstrosity here that doesn't really look like much of anything. So what if we want to actually save this to disk, because we're like, oh, this is so monstrous, we have to show this to someone else. Well, Houdini actually gives us a function for that makes this really easy. So if we go to our parameters and we add a file parameter, maybe even file geometry, I'm actually going to add a separator just to keep this separate. We'll say output file, and hit apply. Let's just actually clear the default, because we don't want to try to overwrite defgeo.bgo. That's not really a useful default. And then we'll add a button that says save geo. Save geo. Now this is not specific to Python SOPs per se, but since we're on the subject of geometry, I'd like to show you guys how this works. So if we hit apply, there's our button. Let's just give it an output file, say in here. Create a new directory called test maybe. And we'll just say test.$f4.bgo. So it'll save it to that directory theoretically. So if we come back to our Python module, and then just say def save geo, who node. All we have to do is get the geometry object, so we can say geo equal who node.geometry, and then do geo.save to file. All we have to do is give this a path, and it'll save it. So what we can do is we can get that path real fast. So we can say path equals who node.eval_parm output file, and then give it path. Hit apply. And what we want to do is go to here and say callback script is kdb_args node.hda module .save geo kdb_args node. So now if we hit apply, theoretically if we hit save geo, it should have saved it to that directory. Let's just make sure that it did. If I go to that directory, there's test0001.bgo. So it did seem to work. If we want to, we can even put down a file stop and see if that worked. And it did. It saved it out. All the attributes seem to be the same, geometry seems to be the same. Now the cool thing about this is that in our Python SOP, we can actually load this geometry inside of our Python SOP. So let's just add a toggle to let users tell us if we want to load or if we want to have live geometry come through. So if we call this live geo, hit apply, that's on by default, and then we'll just add disable when strings for these. So if it's not live, these guys will get disabled because we can't save something that's already on disk. Alright, so let's just go back to our code, and at the very beginning, before we do anything, we'll check to see if we need to load. So if we say live geo equal node.eval_parm live geo, if not live geo, what we can do is just use this geo.load from file. And this function is exactly the same as the save. It just needs a path. So if we get that path, we can say path equals node.eval_parm output file. Give it the path. Now the cool thing about this is that we can load this geometry back in our Python SOP. So let's just add a toggle real fast to let users say whether or not they want to use live data. So we'll say live data, or actually let's just say geo, so it's clear that it's geometry and not some other kind of data. If we hit apply, there's our toggle. And then we'll just, for the save geo, we'll have a disable when string that says live geo equals 0. because if it's not live, we don't want to be able to save it. Alright, so if we come back over here to code, let's look at how we load things back in. So what we can do is first, so what we'll want to do is, the first thing that we'll want to do is check to see if we need to load it from disk. And if we do, then we'll load it from disk, and if not, we'll do all the rest of this stuff. So let's just say if node.eval parm live geo, do all this stuff. And then down here we'll just have our else, and that's when it's loading off of disk. So the first thing that we'll need to do is get the path. So we can say path equals node.eval parm output file. And the second thing we'll need to do is load it in. And we can do that just by saying geo.load from file. And this wants to work exactly the same way as the save to file function. You just want to pass it in the path as an argument. So we can say that. And now if we hit apply, theoretically, if we get rid of this, our geometry disappears the way that we would expect. But then if we turn off live geo, it reappears because it's loading it off of disk. That's what we would expect to have happen. If we turn this off and we say save geo again, and then turn it back off again, you'll notice that it doesn't come back because it's loading it off the disk now. And if we were to put something like blorg here, nothing happens because it's loading off of disk.